How you want to solve it? Elimination? Okay. How you want to set it up? By -3? Okay. So the top equation then stays 3x plus 4y equals 1. And the bottom equation becomes -3x plus 30y equals -18. Then to that I add them. My x's go away. That gives me 34y equals -17. So divide by, not by -17, divide by 34. Y gives me -1/2. Am I done? Into either one of them, right? Okay. So 3x plus 4 times -1/2 has to equal 1. So that's 3x minus 2 equals 1. 3x equals 3. X equals 1. Am I done now? No. What do you got to start? Put it in point form, okay, because we found an intersecting point, or an intersection point, okay? Am I done now? Got to check our answers so we know 100% if we are correct or not, right? Okay? 3 plus -2 is 1. 1 minus -5 is +6. So that works out. So now, after I've checked it, now I'm done. Okay. Thinking back to Algebra 1, what methods could have we chosen? We chose the elimination method. What were the other 4 choices that we had? Substitution. What was that, Kim? Matrices. Cramer's rule. Graphing was the other one. Okay. So that's how we solve. That's the 5 ways, and you've learned 3 of them for sure since Algebra 1. Okay. Added matrices this year. I think you guys saw Cramer's rule before, but if not, added that one this year. So you've seen a ton of those this year. Okay. We've done them a lot. Okay. The problem is those 5 only work when it's line versus line. Okay. Today, what we're going to do is we are going to intersect a line and a circle, or a parabola with a parabola, or a line with a parabola, or a parabola with an ellipse, or a hyperbola with a circle. Okay? Any combination of the 5. Okay? We'll have lines, parabolas, circles, ellipses, and hyperbolas. Any combination 2 of those will be what we're dealing with. Okay? And we call this a quadratic system. Okay?
system is a system that involves one or more conics. Okay? A linear system only involves lines. Okay? Quadratics involve conics. Okay? There are two methods. Well, there's really three methods, but I'm not going to teach you the one because there's really no teaching to be done on it. Okay? The first method is you can use a graphing calculator. Okay? You could. Okay? It's not the easiest to do, but it is. I mean, it pops it up and it, super terrific, fun, happy times. Okay. The other two methods are substitution and elimination. Those are kind of the ones that work for any type of system. Okay. So today we are going to spend talking about substitution and how to solve a system of equations with substitution. Tomorrow we will spend on elimination. Okay? Now, not every single time is the conic going to be given in standard form. Okay? However, you can use what's given to you and what we learned last week, or what I should say, what you should have learned last week, to use that in our brains to kind of say, all right, I should get no intersection points, I should get 1, maybe 4, okay, and so on and so forth. Okay? So you might have multiple intersection points, okay, and you've got to find them all. Okay? So the first question that you ask even before you start this is, what do I have? Okay? So that's the question you need to ask yourself. What kind of a system is this? Okay? Well, you look at your equations. What's the first equation? Why is it a circle, Hunter? Even more. There's three things that make it a circle or an ellipse. Addition sign. Same coefficients. And there's two squared terms. Okay? So all three of those together make this a circle. So yes, this one here is a circle. Okay? Bottom one. What's the bottom one? It's a line. So we've got a circle and a line. So in my brain, I'm going to say, all right, how many possibilities could I have for outcomes in this? Nope. Looking for a circle. All right, well, let's see. So if I my circle, right? Okay. And here is my line. Oops, I should make it a little longer. Right? So I got a circle and a line, right? How many different ways can they intersect? None, 1, or 2. So at most, I can have 2 points that I'm looking for. Okay? But I could also just have 1 point, and I could have no points. Okay? So mentally you gotta kind of prep yourself for that. Okay? I'm looking for up to 2 points in this particular problem. Okay? So step number 1 says you are going to solve one of your 2 equations for x or for y. Which one? We could do y. And which equation? First or second? Second one. And you want to solve for y? Hunter's not sure. Do we want to solve for y in the second equation?
Sure.
Why?
Because it's
It's already done for us, right? Okay? So we've already got that accomplished. Y equals x minus 1. Okay? Now, what we're going to do with that is we are going to put that into, we're going to put x minus 1 into y in the other equation. Okay, it looked like you were like, okay. Right. So this becomes x squared plus, now instead of y squared, I'm going to put x minus 1 quantity squared equals 13. Okay? And now I've got to solve that. Okay? So what is x minus 1 quantity squared?
X squared plus.
Nope. So what is it? So what is it?
Oh, would it be okay? X squared something.
Minus
Okay, minus x.
2x plus 1. By now, you should be able to do x minus 1 times x minus 1 in your brain. Okay? So now what? Even more so than combining like terms. Why did I do that?
You want to set it to 0.
Why do I want to set it to 0? The next step would be to remove a 2, yes, or factor out a 2. Divide everything by 2, yes. But why do I want to get it equal to 0? Why didn't I just leave it as 2x squared minus 2x equals 12? Matt? I don't need to complete this. I mean, I can, but I don't need to. Because I need to, what do we call that? Factor. Because there's a squared term, even more so than because there's a squared term, because there's this linear term right here, I've got to factor it. That's how we solve it. Okay? So you've got to factor this first. But first we said we were going to divide everything by 2, so that gives me x squared minus x minus 6 equals 0. Okay? So does x squared minus x minus 6 equals 0? Does that factor?
Yes.
What to what? Very good. X minus 3 and x plus 2. Now what? How? I said x minus 3 equal to 0, and I said x plus 2 equal to 0. And so I get x equals 3, and I get x equals negative 2.
And then if you kept the 2, you know that 2 wouldn't factor, right? Like
If I would have kept the 2, it would have been 2x minus 6 times x plus 2, or it would have been x minus 3 times 2x plus 4. If I would have kept the 2, that's what they would have factored to be.
Like you factor out the 2.
Oh, if I would have factored it out, then it would have, 2 equals
it
0.
would have.
Yes,
Yeah.
yes, I see what you're saying in that. Yes. Okay. Okay. Now, here's where the tricky part comes. It's in step 4. Find the points. What do I have to do?
You
Okay. Hold on one second. Let me copy this and bring this back down.
Wait, so where does the solving start when you equal it up to 0?
The solving part, so started here
Okay.
and then all the way down. Okay.
It starts when you start.
And it ends when you end. Okay. So what were you saying, India? I'm sorry.
So like you put the x term into the other equation, so it would be y equals 3 minus 1.
Okay. So if I'm going to deal with x equals 3 first, okay? So you're going to say then that's going to be y equals 3 minus 1, so y is equal to 2, correct? Yes? Agree with that? Here's the kicker though. I've also got to put it into the other one, okay? And hopefully I get out a 2, okay? So if I put it into the other one, then I would get 3 squared plus y squared equals 13. So that's 9 plus y squared equals 13. So that's y squared equals 4. So y is equal to plus or minus 2. With me? Okay. Now, I want the y value that showed up in both of them. So it would just be positive 2. So the point that comes out of this one is 3, 2. I don't worry about 3, negative 2 because that only satisfies my circle. It doesn't satisfy both of them. Do you see how I had to plug it into both to get that answer? Now, if I would have gotten something different here in this bottom one, let's say I got plus or minus 5 there, okay? Then that point wouldn't work. That x value wouldn't work because it doesn't double up on both equations. You understand what I'm saying with that? Okay? It's got to show up in both equations in order for it to be a point at the end. Okay? Now we've got to go and do x equals negative 2. In my first one, y equals negative 2 minus 1, so that's going to be y equals negative 3. In my other one, negative 2 quantity squared plus y squared equals 13, so that's going to be 4 plus y squared equals 13. Y squared is equal to 9. Y is equal to plus or minus 3. The one that showed up both times was negative 3. So the other point that comes out of it then is negative 2, negative 3. And both of those then are my answers. Okay? The nice thing about plugging it into both equations is you've already checked it, provided you did your math. Okay? Try one on your own. What do we got first? Circle and a line again, right?
Yeah.
So just like last time, it could not intersect. It could intersect at one point. It could intersect at 2 points. Okay? So I'm looking for up to 2 points. Okay? So I got a circle and a line. Okay? So, already solved for y, correct? Okay? So then let's go x squared plus 2x minus 10 quantity squared minus 25 equals 0. Okay? So that becomes x squared plus 4x squared minus 40x plus 100, then minus 25 equals 0. Everybody agree with 2x minus 10 being 4x squared minus 40x plus 100. Okay? Quick way, when you're squaring, remember, square the first one, multiply them together, then multiply by 2, gets you the middle one, square the last one. Okay? Alright? So this then becomes 5x squared minus 40x plus 75 equals 0, which becomes x squared minus 8x plus 25? 15? I'm sorry. Equals 0. Then factor it. What does it factor to be? X minus 5 and x what? Minus 3. So then x minus 5 equals 0 and x minus 3 equals 0. So I get x equals 5 and x equals 3. Yes?
Yes.
What's up, Kel?
Where you start with 5x squared minus 40x plus 35, how did you get to x squared minus 3x?
Divided every term by 5. Because 5 was the greatest common factor. Could have factored it without it too. Because it's minus 10. That happens. Not the first time. Okay? So, let me bring this back down now. Cappy. Okay? So, let's do 5 first. Okay? So if I do x equals 5 first, in my top one, I'm going to get 25 plus y squared minus 25 equals 0. So that's y squared equals 0, so I get y equals 0. In my bottom one, I get y equals 2 times 5 minus 10. 2 times 5 is 10. 10 minus 10 is y equals 0, also there. So that gives me the point 5, comma 0. Agree with that? Okay. Now let's do x equals 3. In my top equation, I get 9 plus y squared minus 25 equals 0. Which is y squared minus 16 equals 0, which is y squared equals 16, which is y is equal to plus or minus 4. Agree with that? Okay? In my bottom one, I get y equals 2 times 3 minus 10. 2 times 3 is 6, minus 10 is negative 4. So that gives me the point, negative 4 is a number. 3 comma negative 4 is a point. Back up here. 2x minus 10 times 2x minus 10. If I go on the outsides, that gets me negative 20x. If I go on the insides, that gives me negative 20x. Together, that gives me negative 40x. That would be what? Okay. Other questions? Go for it. So, just as a quick poll, how many people left it as is? And put y and substituted for y into the top equation.
Was that the wrong idea?
No, it's doable, okay? But what did you guys find?
It's difficult.
Why? Because it's a fraction.
So we should have multiplied everything by 2.
Multiplied everything by. So let's multiply the bottom equation by 2, right? Okay? We're going to multiply this whole equation by 2. That gives me 2y equals negative x plus 8.
Well, that's so much nicer.
Okay? Now what?
I can probably actually solve it.
I multiplied by 2 to get rid of the fraction.
We have to solve for y.
No.
Oh no, you're gonna switch it to x.
I'm going to switch it to x. So that's going to give me x equals 8 minus 2y. Agree?
Yeah.
Now, how many times do I have to substitute that into the other equation? Once, which is easier than twice. Okay? Sometimes, if you take a peek down the road, you will see that there's rocks up ahead. Okay? So maybe you want to turn and go a different way. Okay? So this becomes y squared minus 10y minus 8 times 8 minus 2y plus 57 equals 0. Which is y squared minus 10y minus 64 plus 16y plus 57 equals 0, which is y squared plus 6y minus 7? No. 3, 6, 7, yep. Equals 0. I get y plus 7 and y minus 1 equals 0. Okay. Then we got to go back up here and we got to steal. Okay. So -7 first. So that's going to be 49 plus 70 minus 8x plus 57 equals 0. So what is that? 119. $176? So that's going to equal 8x then, right? So that's 22.
Yes?
Okay. Then in the other one, -7 is going to equal -1/2 x plus 4. So subtract 4 is going to be -11 equals -1/2 x. Multiply, both sides by -2. 22 is going to have to equal x. So that produces the point 22, comma, -7.
Yes?
Okay. The other one is y equals 1. Minus 10 minus 8x plus 57 equals 0. So that is -948. 48 equals 8x, so that gives me 6 is equal to x. In the other one, 1 equals -1/2 x plus 4. Subtract 4 is -3. Multiply by -2 gets me 6 equals x. So that produces the point 6, comma, 1.
If you plug in those to the second equation, would be that x equals 8 minus 2y? Or would you want to?
I always go original, but I've gone original forever, so.
Would it still work?
Yeah.
Okay.
Provided you did your math right the first time. But if that's where you made a mistake, then your answer, you know what I mean?
Yeah.
So if you go original, then
You'll know what you made a mistake. That actually makes sense.
okay.